Hi, I'm Sharon Mackless at IDG, here with episode 39 of Do More with R, Points in Polygons. Calculating which polygon a point belongs to has all sorts of uses. For example, this powers apps that tell you where you vote or who your legislators are. In this episode, I'll use points in polygons to answer a simple question. What zip code is that street address? We'll need just three things for this. 1. A way to geocode an address to get its latitude and longitude. 2. Shapefiles that outline zip code boundaries. And 3. The SF package. For geocoding, I usually use the Geocode.io API. It's free for 2,500 lookups a day, but you do need an API key to use it. To get around that bit of complexity for this video, I'll use the free open source OpenStreetMap API. It doesn't require a key. The TMap Tools package has a function, geocode_OSM, to use that API. So let's start coding. First, I'll load the packages I want, SF, TMap Tools, and also TMap and dplyr. Next, I'll create a vector with two addresses, our IDG office in Framingham, Massachusetts on Old Connecticut Path, and the RStudio office in Boston. And then I'll geocode them with the geocode_OSM function. You can see the results of the first couple of columns here. I've got a latitude column and a longitude column. For zip code boundaries, the U.S. Census Bureau has one zip code tabulation area file for the entire U.S. It's a pretty big file. Instead, I went to censusreporter.org and searched for data just for Massachusetts by zip code area and downloaded that. Let me show you that. Here's censusreporter.org. I'll start searching for Massachusetts. I can do pretty much any data. I'll do total population. I can add zip codes here so I get the data by zip code, and then I can download the data as a shapefile. I did that in advance to save a little time. You could also use the Tigris package to download a census shapefile, and a lot of other alternatives. Let's get back to R. I could unzip my downloaded file manually, but it's easier in R. Here I use base R's unzip function on the file that I downloaded. This junkpaths true argument just says I don't want unzip adding another subdirectory based on the name of the zip file. So let me unzip the file. Okay, now finally some geospatial work. I'll import the shapefile into R using SF's st_read function. Okay, look down here at the bottom left at the console. There's some information displayed there, and at least one of those data points is important. The EPSG. Here it was 4326. Without getting too deep into the weeds, an EPSG basically says what system was used to translate areas on a three-dimensional globe, the Earth, into two-dimensional coordinates, latitude and longitude. This is important because there are a lot of different coordinate reference systems, and I want my zip code polygons and my address points to use the same one so they line up properly. My file happens to have an overall polygon for the full state of Massachusetts, which I don't really want, so I'm just going to filter that out with the next code here. Okay, this next code here isn't really necessary, but it's a nice check of my shapefile. I do a quick plot of my zip code SF object with TMAP's QTM for quick theme map. So let's run that code and wait for the result. And if we take a look here in the bottom right panel, it does look like my geometry seems consistent with Massachusetts zip codes. Next, I want to use my geocoded address data. This is the one part that gave me trouble when I first started using SF. Right now, the latitude and longitude are stored in a plain data frame, but it needs to be converted into an SF geospatial object and with the right coordinate system. I can do that with SF's st_as_SF function. And by the way, SF functions that operate on spatial data generally start with st_. If you're wondering why, that stands for spatial and temporal. So st as SF takes several arguments. In this code, the first argument is the object to transform, my geocoded addresses. Second, I'm telling SF which columns have the x, longitude, and y, latitude values. That's here. Third, I'm setting the coordinate reference system to 4326, so it's the same as my zip code polygons. And let me run that. Now that I've set up my two data sets, calculating the zip code for each address is super easy. I just use SF's stjoin function. That uses this syntax: the point SF object, the polygon SF object, and the type of join. In this case, I'm running stjoin on the geocoded points first, the zip code polygon second, and my type of join is st_within. The order of the objects means all points are included from the addresses, but only matching zip codes in the polygons. And again, my type of join is st_within because I want to calculate which polygon the points are within. stjoin, my points, my polygons, st_within. Let's run the code. Super easy. That warning happens pretty much all the time. Let's take a look at my results. I can print it out here. You see it's EPSG 4326. And right here under the column name, I've got zip codes. You can see that a little easier if I open that here. There we go. 01701 for Framingham, 02210 for Boston. If you'd like to map that, here's one way you can do it with TMap, looking at both the points and the polygons, using TM shape, TM fill, and then TM bubbles for the points. And there's the map of zip codes and points. That's it for this episode. Thanks for watching. For more R tips, head to the Do More with R page at go.infoworld.com/morewithR, all lowercase except for the R. You can also find the Do More with R playlist on the YouTube IDG Tech Talk channel, where you can subscribe so you never miss an episode. Hope to see you next time.